Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 1.3, in which we solve equations with variables on both sides. We already know the properties. We've already covered the properties that we're going to use to do this. Now it's just a matter of applying it to terms that have variables in it. Okay, so let's take a look at the core concept here. We want to, again, to solve an equation with variables on both sides, simplify one or both sides of the equation if necessary. So we've already worked on simplifying sides of the equation and then using inverse operations to collect the variable terms on one side. So this is the new idea, collecting the variable terms on one side and the constant terms on the other side, okay? So that's the big idea here. That's the only difference from what we did in the multi-step equations. So let's take a look at some examples here. Okay, so I've got 10 minus 4x equals negative 9x. And we said that we wanted to collect the variable terms on one side. And to do that, we're going to use the addition property of equality. So to get rid of I want to move the negative 4x to this side. You don't want to move this. We don't want to move the negative 9x over to this side because remember we're trying to isolate the variable terms on one side, the constants, which are just plain numbers, on the other side. Addition property of equality says that if I can add the same thing to both sides, so I'm going to add the positive 4x to both sides to make that a 0. So that leaves me 10 equals negative 9 plus 4, negative 5x. Okay, so I've got my constants on one side, I've got my variables on the other, and I've simplified them, and now I am going to just get rid of the negative 5 times the x by dividing both sides by negative 5. And that leaves me 10 divided by negative 5 is negative 2. And of course, negative 5 divided by negative 5 is 1. 1 times x is x. And there's the solution to the first one. Let's check your solution. Just look at this negative 2. If I put negative 2 in up here, negative 2 times negative 4 is it's going to be 8. And over here, it would be negative 9 times negative 2, and that's 18. So if I add these together, I'll have 18 equals 18. So I have a true equation. Okay, that's how we're going to check that. A little more complicated one here, because the first thing we have to use is the distributive property to multiply through these parentheses here and get rid of the parentheses. We cannot apply addition property, subtraction property to both sides here if we have parentheses. So the first thing I'm going to do is distribute. So 3 times 3x is 9x, minus 3 times 4 is 12. Now 1/4 times 32, that's really the same thing as dividing by 4, right? So it's 32 divided by 4, so I have 8x. And then 56 divided by 4 is 14. Okay, so now I've simplified it down. So I have, I still have a variable term on both sides, and I have constants on both sides. So I'm going to go ahead and subtract 8x from both sides. Now you're more than welcome to subtract the 9x from both sides, but if I do that, I can look at this and say, well, that's going to leave me a negative x, and this way I get left with a positive x, and that's probably a little bit better. And then I can do it in one step here. If I want to, let's say, add 12 to both sides, I can go ahead and do that. 14 and 12 is 28. And that's done. You can show that as two separate steps. You can simplify. The first step and then show adding of 12 on this on the next step. But nothing we did in the first step would affect the second step anyway, so I'm allowed to kind of do it this way. Okay, special solutions for linear equations. Now this is very important. Equations do not always have just one solution. do not always have one solution. An equation that is true for all values of the variable is called an identity, and it has infinitely many solutions, which means any number, any answer would work. And then an equation that is not true for any value of the variable has no solution. So just real simply, let's say I was to say x plus 1 equals x minus negative 1. It doesn't matter what x is here. This will always be a true equation. So something like this will have infinitely many solutions. And if I said x plus 1 equals x minus 1, this will never, ever be true because it doesn't matter what x is. The left side, I'm going to increase it by 1. The right side, I decrease it by 1. It will never be equal. So this would have no solution. So let's take a look at what it looks like with one of our problems here. Again, I'm going to use the distributive property here. 3 times 5x is 15x plus 6 equals 15x. Okay, now you can look at this right now and see this is going to be no solution. But let's go ahead and simplify it out all the way through until we have no variables left. And I'll show you that, how to go through all these steps here. Okay, I'm going to follow the same steps we were following before. I'm going to combine my x's on one side of the equal sign. So that's going to leave me 6 equals 0. Okay, the variable terms are gone. Okay, and I have an untrue, left with an untrue statement. Okay, so if I get left with an untrue statement, this is no solution. Let's take a look at the second example here. Same thing. I'm going to multiply through to simplify the left side. So negative 8y minus 2 equals negative 8y minus 2. So you can see right here, these are the same thing. This is going to be infinitely many solutions. But let's follow this through all the way like we practiced before. I'm going to add 8y to both sides. I'm trying to combine my variable terms on one side. So that will cancel, and this will cancel, and that leaves me negative 2 equals negative 2. So again, the variable terms are gone. And I have a true statement remaining. Right, because negative 2 equals negative 2. So the answer here is going to be infinitely many solutions. And if we go back and just look real quick, an equation that is true for all values of the variable is an identity and has infinitely many solutions. So this is equations called an identity. Because again, it doesn't matter what we put in for y here, this will always be true. Over here, it doesn't matter what we put in for x, it can never be true. So no solution, infinitely many solutions. Okay, so get these into your notes. This is kind of a summary of all the things we've done in the first 3 lessons for solving equations. Basically, we simplify each side of the equation. Now, they've kind of broken this down into using the distributive property and then simplifying kind of together in my mind. And then collecting the variable terms on one side of the equation and the constants on the other side. This is when we have variables on 2 sides of the equations. You got to get them all together on one side. The constant terms are just plain numbers on the other side. Isolate the variable, which you should probably already be able to do. Hopefully you can do all this by now, and then check your solution just to make sure that you have correct answers. There's no real reason on a test or a quiz or something where you turn in a wrong answer. You can check it to see if it's right or not. And that's it. Okay, I'll see you in class, and have a really, really good rest of your day. All right, bye, guys.